Independent events are those that do not affect the probability of each other. So in a couple of minutes, going to have a look at Rudolph and some antler warmers. But first of all, let's have a look at what happens when we can flip a coin and then choose a sweet out of a jar. Now, we can use a tree diagram for this. We start off with our branches for our possibilities. So it's possible to get heads or tails, and the probability of getting a head is a half, and the probability of getting a tail is also a half. Okay, that's our first event. So the second event, so we could have flipped the coin and got a head. That does not affect the outcome of picking a particular colour from the jar, which is why these two are independent. So the two possibilities when picking out of the jar are red and green. The probability of picking a red, well, there are 3 reds out of 5 in total, and for greens there are 2 greens out of 5 in total. Going back down to if we got a tail, we then have some more branches. So we still had the options of getting a red or a green, and the probability of getting a red was 3/5, and for green 2/5. So going from the beginning, we can get a head and then we can get a red, or going back from the beginning again, a head and then a green, or at the beginning again, getting a tail, then a red, or getting a tail and then a green. So the outcomes would have been head, then red, head, then green, tail, then red, tail, then green. And for calculating these probabilities, so we have a half, because we had a head, and a red, so that's 3/5. And we multiply these probabilities. So a half multiplied by 3/5. So multiplying the numerators, 1 multiplied by 3 is 3, 2, and then multiply the denominators, 2 multiplied by 5 is 10. And we do that the same for all of the other branches. So 1/2 multiplied by 2/5. So 1/2 multiplied by 2/5. Multiply the numerators, multiply the denominators, and you'll notice that each time we're getting the same denominator. So for the next one, 1/2 multiplied by 3/5 will give us 3/10, and 1/2 multiplied by 2/5 will give us 2/10. Now we know that the total probability will add up to 1, and we can check that no mistakes have been made in any of the working out. So all 4 of these should add up to 1. So we have our 3/10 plus 2/10 is 5/10, plus 3/10 is 8/10, plus 2/10 is 10/10, which is equivalent to 1. So the probability of picking a head, of flipping a head, and then picking out a red from the jar is 3/10. Now we can also look at something a little bit more complex. So the probability of picking out a head and green or a tail and green. So for a head and green, we're looking at 2/10, and a tail and green is also 2/10. And for this, we therefore have our 2/10 plus 2/10, which gives us 4/10. Okay, going back to Rudolph then. So, in Rudolph's antler warmer draw, each day he will randomly pick out a special set of warmers for his antlers, and he has a choice of those 4 colours. So the probability of picking out any particular colour, so for example, let's go for orange. We know there are 1 pair of orange out of the 4 in total. At the end of his run, he'll go and put the antlers back into the draw, and the next day he'll then go to the draw and randomly pick out another pair, which again will be a quarter because there are the 4 pairs in the draw. So the probability of picking out an orange pair 2 days in a row, so that would be orange and then orange. So we know the probability of just picking orange out once is a quarter, but then picking out orange again for the second time, we multiply by a quarter. So when we have this language that we're using here, and with probability, that means multiply. So the probability of picking an orange pair and then another orange pair is a quarter multiplied by a quarter. So multiplying the numerators, multiplying the denominators, so it is 1/16.